All right, physics fans, Mr. Russo. It's the introduction to Unit 8, the end of mechanics, and the start of learning about things that we don't have a full understanding of. So, hope you're comfortable with that. All right, so we've got fundamental forces. And keep in mind that when I was a kid, there was only 4. So our understanding of physics has grown hugely in the last 30 or 40 years. So we've got the 4 fundamental forces that I knew about are gravity and electromagnetism, which we would consider macroscopic, and they operate over larger distances. And then you've got the weak and the strong nuclear force, which hopefully you learned about in chemistry, right? And those are driving what's happening on the atomic level. All right, and so gravity is a relatively weak force, and it follows the inverse square law. And because we are so close to Earth, that's why it seems to rule us. All right, you've got one formula. There it is, right? And the force of gravity is equal to big G. Remember earlier in the year that I made a big deal over whether it was a little g or a big G? Well, here's why I make the distinction. There is big G, the universal gravitational constant, which may or may not be constant. There's more on that coming. And the mass of object 1, the mass of object 2, and the distance between them squared, if you put a d or an r, right? Radius, usually things that we're talking about, forces of gravity, are orbiting, so we use radius for a circular orbit. And we do know that orbits aren't quite exactly circles, but they're close. All right, there we go. Take a look for a moment at the value of big G right there below, right here. And you'll notice its value, 6.674 times 10 to the minus 11th. Ooh, that's a small number. And then the units, oh, those are ugly. Newton meters per kilogram squared. Wow, why are they so ugly, Mr. Russo? Well, I call this constant like a fudge factor, right? Because when people were doing experiments with gravity, they were realizing that they were always off by a certain amount. And there it is, big G. It's a teeny amount. And look at those units. They talk about newtons, which are force, meters, which is distance, and kilograms, which is mass, but squared. So it's hinting at me that this is about the density of space, right? It's about how matter is spread out through the universe. And really, this also hints at the grand unified theory. If you haven't heard about that yet, you might have a chance to do that in this unit. And it is one theory to tie all of the things together so we can explain physics one way. But we don't have all the pieces yet. So while all the things we've done so far in physics have been fairly straightforward, easy to measure, and pretty much follow the rules, we're getting into a place where they don't. We don't have all the answers. And I kind of find that interesting, right? And then at the bottom, just a few planets and a star that we like, right? And there's their mass, their distance from Earth, and the value of little g on those bodies. And look at those, the sun. Woo! Good luck jumping if you could stand on the sun. Same with Jupiter, right? Mars, not so bad. Venus, nearly identical to Earth. And the moon, 1/6 of Earth. All right, so this worksheet could be your notes, will be your notes for the unit. And I will post it in Google Classroom shortly. All right, so that's one of your tools that you will need. The other things you will need is the worksheet for the day, a pencil, spare pencils, eraser in case you make a mistake, and of course, your calculator. All right. Well, let's model those steps of problem solving, shall we? Step 0. Well, there's no sub-zero because there's no instructions, but I think as seniors in high school and some juniors that you know, you fill out the worksheet. All right, find the force of gravity between two planets if their respective masses are 6 times 10 to the 24th kilograms, that's a mass, and 5 times 10 to the 13th kilograms. Well, if I paid attention to that table that I just showed you, this looks to be about planetary scale, and this looks to be about like a moon scale. But it doesn't matter. I can still find the gravity between them. It doesn't matter if they're planets or not. And this, 6 times 10 to the 16th meters apart. That would be my R. And it says, find the force of gravity. All right. Well, I only have one tool in the toolbox, so let's just copy it down. Force of gravity equals big G, M1, M2 over R squared. There we go. If you've just done that, you've got a 7. Move along. But if you'd like to earn all the points, let's plug in our values, right? Value for big G, 6 point, just look on my sheet, 674 times 10 to the minus 11th, right? And those are newtons, meters per kilogram, and that's squared, right? Times mass of planet 1, 6 times 10 to the 24th. I'm also noticing that my significant digits are at 1, right? And mass of planet 2 is 5 times 10 to the 13th kilograms. And distance apart, 6 times 10 to the 16th meters, right? And that's important right there. So one of the things that will get you in trouble in this particular worksheet is arithmetic, right? You'll drop some of your exponents, you'll forget to square this, and you'll get a very large number or a very small number, right? But when I do the units, meters squared cancels with meters squared, kilograms squared cancels with kilograms squared, and I'm left with just newtons, which are the units of force. All it is arithmetic now. So, life hack. Here we go. On your calculator, here is a new friend. This will save you, always hit clear, right? This will save you a ton of effort. I'm trying to get this at the good angle. All right, so this is the button right here. Do you see that? EE? That's your exponent button. Each entry, that'll save you like 5 or 6 keystrokes, right? So, and here's another life. So second life hack. Instead of typing the value of big G 5 times, I'm going to go like this, 6.674, right? Then I have to hit second EE, right? And that E on your calculator stands for times 10 to the. There we go. And then it's going to be negative. I think that's the negative button. I think I should get a fresher calculator. Oh, yes, I was right. So now what do I do with that? I'm going to store it in memory. I'm going to store it in A, right? Just hit enter. Now it's in memory A, and I don't have to keep typing that. So how many keystrokes did I just save? All right, so just hit clear, and I have that value. All right, here we go. Let's do some math. I'm going to go recall, right? So second memory, I'm going to recall A. There it is. Times 6 second EE 24 times 5 second EE 13 divided by 6. I'm gonna do parentheses just in case. 6 second EE 16, close parentheses, and then that value squared. Here we go. Oh, it's teeny. It's a very small number. All right, so if you wanted to write that, you could do that, right? The force of gravity is equal to that very small fraction, or I could go negative 1, 2, 3, 4, 5, 6, right? I could go 5.6 times 10 to the minus 6 newtons. Box my answer. All right, you can also make the calculator do that for you. But there you go. That's how you do these problems. Quick pause. Those of you who don't need me anymore, you can complete the worksheet. I'm going to run down to number 4 because I find that is where some people get hung up in the algebra, right? And again, this course is not about harming you because of your math skills. So, find the mass of 2 identical planets. That's my unknown. If the force of gravity, that's F of g, so I know F of g in this problem, and they are 8.2 times 10 to the 21 meters apart, so that's my R. Again, I have one formula. I write it down. Force of gravity equals big G, M1. Oh, in this case, it's 2 identical planets, so I'm just going to call it mass of planet, right? M sub P. Doesn't matter what I call it, right? And then that's going to be squared because it's times itself over R squared. Then, these are big numbers. I'm not going to just start plugging those in and try to do algebra and arithmetic at the same time. I'm just going to do my algebra skills on this. I am looking to get this one all by itself. Okay, so this becomes, right? I'm just going to multiply both sides by R squared. So it's FG R squared. Right? Divide both sides by big G to make it go away. And then I'm left with MP squared. How do I undo this? I square root both sides. Square root. If I do it to one side, got to do it to the other. So, finally, I'm almost there. Right? This becomes, I'm just writing it left to right. MP equals root F force of gravity R squared over big G. There we go. I'm going to let you do the arithmetic on yourself. I helped you with the algebra. There you go. And that concludes our lesson for the end of mechanics. Good luck on the other 3 problems. The answer key is always available. And so the math gets easier, I think, from here on out. Over and out. And always ask questions if you have them.